and welcome back. In the last lesson, I introduced you to two different shortcuts for proving that triangles are congruent. We looked at side angle side and side side side. And remember, with the side angle side, we had to have two sides that were congruent and then an angle that was in between those two sides. Well, we have something kind of similar for this one. This time we have an included side. And an included side is the side located between two consecutive angles of a polygon. So this brings us to our next shortcut, which is the angle side angle congruence, or the ASA congruence, which says that if two angles and the included side of one triangle are congruent to the two angles and the included side of another triangle, then the triangles are, no surprise, congruent. So let's give this one a shot. In the last lesson, I kind of introduced you to proofs, but we're going to do them a little bit more sophisticated this time, a little bit more official. So it says use ASA to prove that the triangles are congruent. We're given information just like we were last time, and this time we're going to prove that PQS is congruent to RQS. So just like we did before, we're going to start with looking at the statements, marking the triangles to see what we have, and giving reasons for each step. So the given information we have this time is that QS, let's write that one right in the middle, bisects PQR, that angle. And then that PSQ is congruent to RSQ. So PSQ is congruent to RSQ. So PSQ is congruent to RSQ. So I'm gonna put some markings in there. Okay, so here we go. I've already put in with the first statement for you that QS bisects angle PQR and that PSQ is congruent to angle RSQ, and that's just the given information. And so what we have right there is, I'm going to write over on the side, we've got an angle that we know is congruent there. Now two, we're out of we already wrote down all of our given information, but we haven't necessarily used that information yet. So QS bisects PQR, which means that if it bisects it, it cuts it exactly in half, which means we've got one new set of congruent angles. So we know that angle PQS is congruent to angle RQS. And we know that because of that angle bisector. Okay, so we have another angle that we know is congruent. We're supposed to be using angle side angle to prove that these triangles are congruent. So we need a side to work with, and we need it to be the included side. So the included side between those two angles is that one smack in the middle of our little figure here. But you know what? Like we did in the last video, the triangles share that side. So we can say that that side is congruent for each triangle. So we can say that QS is congruent to QS because they share the side. But remember, the official thing for that, like share the side, it's the same side thing, is called the reflexive property. Reflexive property, like looking in a mirror, QS equals QS, reflexive property. And this side is actually an included side. So we can say that the two triangles are congruent, PQS is congruent to RQS because of the side angle side congruence. Let's do another one of that one. So here we have another figure, and we're given that ZX, let me put it in highlight, ZX bisects WZY, so it bisects that angle there, and XZ bisects YXW, YSO. So that line in between there bisects both of the angles that it hits on either side of our parallelogram. And we want to prove that WXZ is congruent to XZY. Well, let's just start writing stuff down and see where we go. So first of all, we need some statements. In general, it's always good to start with the given information. So we know that ZX bisects angle WZY and XZ bisects angle YXW. And the reason we know that is because it's given information. It's not really a side or an angle yet, so what does that tell us? Well, if ZX bisects WZY, that means that these two angles are congruent because the bisector cut it smack in half. So that means that WZX, angle WZX, is congruent to angle YZX because of the angle bisector. And similarly, on the top side of the triangle, we could say that these two angles are congruent because of the angle bisector. So we could say that angle WXZ is congruent to angle YXZ because of the angle bisector. Okay, so those are both angles. Those are both angles. We have two angles. Do we have an included side? Do we have an included side for those? Well, I love this thing. When they share a side, that's such a great go-to. The triangles share this side, so we can use that. So we can say that ZX is congruent to ZX. Looking in the mirror, that's called the reflexive property. So now with our two triangles, we've got an angle, an included side, and another angle. So we know that angle WXZ is congruent to triangle X. That's not an X. XZY because of the side, angle, side congruence. Flipping over on the back, I have one more shortcut to show you. So we've done side, 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 angle, side, angle, and the last shortcut that we have is angle, angle, side. Angle, angle, side. So for angle, angle, side, it says that if two angles and the non-included side, this time we're using the non-included side of one triangle, are congruent to the corresponding two angles and sides of a second triangle, then we know that those two triangles are congruent. So we're going to try it with a proof, and we're given that DAC is congruent to BEC. There's no markings on this one, so we need to mark as we go so we can keep track of what we're doing. We need to prove that ACD is congruent to ECB. Let's highlight those so we know what we're doing. ACD, okay, there's that one, is congruent to ECB. ECB is that one. So those are the two triangles, that blue one and that green one, that we need to prove are congruent. Okay, so we know that DAC, we'll just write this down, angle DAC is congruent to angle BEC, and that's given. and DC is congruent to BC. Also given. And so that's an angle, that's a side, and let's mark these. So DAC is right here, and BEC is here, okay? And then we've got DC is congruent to BC. So DC is congruent to BC. So we have one angle and one side. We need more than that. Remember when we were working on the front side of this paper, when they shared a side, we could use that, and we called it the reflexive property. We can also share angles if they share angles. And look at both of these triangles share angle C. So we can put that one in there. So we can say that angle C equals angle C because of the reflexive property. And if we're going to use the angle side congruence, it has to be two angles and the non-included side. So do we have that? Now, it gets a little bit confusing when there's all these, when they're kind of like all twined. But if you just look at the green one, let's look just at the green triangle. We've got angle E, angle C, and then the side BC. So that's two angles and a non-included side. For the blue one, we've got angle A, angle C, and then this side DC. So for both of them, we do have two angles and a not included side. So we can say that triangle ACD is congruent to triangle ECB because of the angle side congruence. Okay, we've got one more to try. Same kind of process. Let's see what we can do here. We're going to prove that two triangles are congruent. We're given that angle K is congruent to angle M. Angle K is congruent to angle M. Make sure you mark it every time. Angle K is congruent to angle M. That's an angle, and that's given information. And then JK bisects angle KLM. And we know that JK is congruent to JM. Kind of looks like an R. JK. JK is congruent to JM. Okay, so that's a side. So I've got an angle and a side. And if we're trying to use the angle side congruence, then I need another angle. Now we haven't used this information yet that JK bisects KLM. So if it bisects KLM, that means that these two angles are congruent. So let's write that down. We've got angle KLJ. Angle KLJ is congruent to angle MLJ. And that's because of the angle bisector. And that's an angle. And let's see. Oh, look at this. This is nice because we've got angle, angle, side. Angle, angle, side. The corresponding parts are congruent. Two angles, and that angle actually can go right up there. So we know that triangle JKL is congruent to triangle JML because of the angle, side congruence. Cool, huh? Thanks for being here.